Hi everyone, welcome back. In this video, we'll see an example MapReduce program. This is a famous word count example. It's like the hello world of Hadoop. Let's first look at what the input is and what we will get in the end as output. As input, we have a collection of text files. For simplicity, we use only two, and each file contains only one line of fruit names. Just eyeballing those words, you can already tell the answer. That is apple 4 appearing 4 times, grapes 1, mango 2, and so on. So again, given a collection of text files, we want to know every word's frequency. This is a small data set, so you can easily fit all the text files in memory and then count the words using your favorite methods and data structures, such as arrays, maps, dictionaries, and so on. But imagine you have billions of text files and millions of words. Can you still fit all of that in memory? Likely not. How do you write a MapReduce program so you can do this for such large data set on Hadoop? Let's take a look. This is a one-page summary of the MapReduce program that will do that. It may look a little scary in the beginning, but it's actually quite simple. It is like a flowchart that describes the MapReduce program. We have the input files on the far left and the output on the far right, which are exactly what you saw previously. Now we see concretely how the master computer divides up the work, where each piece is a single file. That is, suppose the first file has 2 lines. Now the first line, apple, orange, mango, becomes 1 unit of work. And this line is processed by a mapper computer in the map phase, where data and computation are divided up into pieces, and each mapper computer handles one piece, independently and in parallel. Here, each mapper does a very simple thing, which is to turn each word that it sees into a key-value pair. For example, when it sees apple, the mapper outputs apple 1, where apple is the key and 1 is the value. Now you know why the worker is called mapper. The reason is that it maps an input, which is a single word, such as apple, into an output that is a key-value pair. Now we have many such key-value pairs. If you can scan them quickly, you see that every word occurrence is associated with a 1. This is great because we can exactly get the result if somehow we can group all the 4 pairs of apple 1 together. Then we get a result, which is apple 4. Similarly, if we can group the 2 mango 1 together, we get mango 2. So how do we group them? Fortunately, this is automatically done for you in the shuffling phase. All the key-value pairs that you've got after map phase are automatically sorted by their keys and moved to the reducer for processing. This means all the apple 1 will be grouped together exactly what we want. So for example, the reducer that handles the apple 1 key-value pairs will see 4 of them as input. And it can easily add the 4 ones, and we get our final output. What you just saw was a simple but complete MapReduce program. And this exact same program would also work for large data sets with billions of files and millions of words. In other words, if you want to write a program to handle large data sets on Hadoop, the most important thing is to figure out how to express it as a series of map and reduce operations. The main implementation for the program you just saw is actually also quite simple. You only need to implement 2 functions. The first one is the map function, which takes in 1 line from an input file, break that line into individual words, and then output the word and a 1 as a key-value pair. The second function is the reduce function, which will see a list of key-value pairs as input, and all it does is add up the values and then output a key-value pair consisting of the same key and the result of the addition. One thing to note here is that in the input, instead of a list, we see an iterator. The reason for using an iterator is so that we don't need to know the number of items beforehand, so that we can iterate through billions of items without having to worry about allocating enough memory for them. In this video, we saw a simple but complete MapReduce program that would work for both tiny datasets and datasets with billions of files.